Good evening, and welcome to the first of three videos covering Chapter 2 in your textbook, which is entitled Statistics and the Research Process. Now, uh, we have already talked a little bit about what statistics are and why we need to study them, and what they can be useful for. But the most important thing that we're going to do this summer is a research project in our science class. And I'm going to teach you some statistical analyses for that class, but I'm also going to concentrate on why it's important to use statistics in research. All right, and that's really what the point of this chapter is. All right, statistics and the research project or process. When a scientist or any researcher carries out an analysis of a set of data, they need to make sure that the data actually shows what they claim that it shows. And the way that they do this is by statistics. So, our goals in this chapter are really going to be to outline some of the things that you need to know when you set out to do a research project. All right. So, the goals of this chapter include the logic of samples versus populations, how to recognize a relationship between uh, two different variables, what is meant by the strength of a relationship, and finally, what descriptive and inferential statistics are actually used for, all right? Because there are different kinds of statistics that are useful in different scenarios. So, um, in terms of all of these definitions, just don't get too stressed out about them. Just try to understand the differences between them. All right, most of the things on that previous slide are dichotomous in nature, this or that. All right. Now, other goals of Chapter 2 include to know what the difference is between an experimental study and a correlational study. We'll be going over this in our science class as well. All right. Um, how to recognize what we call the independent variable versus the dependent variable in an experiment, as well as being able to identify the conditions of the experiment. Was the experiment carried out in the best possible manner? Right? And finally, the last thing in Chapter 2 is a discussion of the four kinds of measurements that can be made. So we're going to look at what the four scales of measurement actually are. Okay, so that brings us to the beginning of our discussion of Chapter 2, all right, the logic of research. All right. When scientists go out to research something, or when anybody goes out to do research, all right, they're trying to determine the cause and the to a certain effect. You make an observation and you see something happening, and you're trying to demonstrate that X causes Y, all right, or some factor affecting X causes what we see in Y. All right. And so the entire logic of a research project goes into trying to form a cause and effect relationship. All right. So that you can actually see it and demonstrate it to the people who are reading your chapter, your paper, your book, whatever it happens to be. All right. Now, scientific research is essentially all about looking at the laws of nature. Now, there's all sorts of scientific research. There's physics, there's chemistry, there's biology, earth science, and so on. Um, the research that most of you will probably do as liberal arts student will be behavioral in nature. All right, and so you're not going to be studying the physics or the chemistry or even the earth science. You're going to be looking at the biology and why people behave the way that they do. Okay, and so behavioral scientists also are studying the laws of nature, and so therefore they are subject to the same rules that apply to physical scientists and chemical scientists and so on. What behavioral scientists do is examine how specific influences govern the behaviors of a particular group. All right. So, um, how does the presence of laptops in a classroom affect the behavior of those students? Okay, does it allow them to do better work or not? Okay, I know for a fact that when the iPads are plugged in and not being played with by my children are far more attentive to me than they are if the iPads are out. Right, if they're staring at a screen and I try to get their attention, it's hellacious. All right, it's terrible. Now, so what we do as behavioral researchers is we examine how specific influences govern the behaviors of a particular group. Okay. And then we generalize back to broader behaviors and the laws with which we began. So, for example, if I wanted to make a general statement about the effect of iPads on 13-year-olds, I could use my triplets as a sample and uh, make a general statement that their behavior is probably similar to the behavior of every other 13-year-old. Now, it may not be, but because 3 is a fairly small sample size, but it might be. Okay, so that leads us to the second major thing that we need to talk about here, and that's the difference between a sample and a population. Now, if I wanted to really figure out what the effects of iPads were on 13-year-olds, I'd have to study every 13-year-old in the entire world, the entire population of 13-year-olds. Now, that's a big ticket to punch here. And so in reality, what I'm going to do instead is I'm going to take a sample of 13-year-olds from upstate New York, and I'm going to use those to make broader generalizations about a population. So, what's the difference between a population and a sample? Well, the entire group of individuals to which a law of nature applies is the population. Now, the population can be, New Yorkers or freshmen at Siena College or squirrels on Siena's campus. All right, that's you define what the population is. All right, and in some cases, you may be able to actually sample the entire population. But in reality, for most analyses, you can only get a small portion of the population in your study. So, a sample is a relatively small subset of a population, okay, that's intended to represent or stand in for the population. So, um, if you wanted to test, some hypothesis about the squirrels on Siena's campus, you would have to catch every squirrel. Is that going to be possible? Probably not. All right. So you catch, let's say 20 squirrels. All right. And we use those 20 as a sample. And what they do, that those 20 squirrels represent the 200 squirrels that live on Siena's campus. All right. I don't know how many squirrels actually live on Siena's campus. I'm just giving you an example here. All right. So if the population has a size of 200 and you are able to measure 20 of those, the 20 is a sample of the population of 200. Now, the individuals that we measure in a sample are called the participants or the subjects. All right. I'm not really sure that you can call a squirrel a participant, so we probably just call them subjects instead. All right. And of course, each individual is going to give us a data point. Now, the scores that those data points give us in that sample can then be used to infer or estimate the scores that we would expect to find in the population. All right. So, assuming that we caught 20 squirrels and we measured the tail length of a squirrel, all right, we would probably find a range of tail lengths between, I don't know, maybe 20 centimeters and 30 centimeters, let's say, all right, with an average of 25 centimeters. Okay. What we could infer is that all the squirrels in our population of 200 had an average tail length of about 25 centimeters. Okay, we didn't measure all 200 squirrels. We only measured 20 of them. All right, but the average of those 20 is we're assuming that that is a reasonable sample of the 200, and so from those 20 with an average tail size of 25 centimeters, we can assume that the average tail size in the entire population is 25 centimeters as well. All right. I hope that makes at least some sense to you. Okay. If you were trying to measure some aspect of every person on the entire planet, you'd have to measure 7.5 billion people. All right. That's probably not possible. And so instead, we take a smaller sample, maybe 1,000 people, maybe 200,000 people, maybe 1 million people. Although now we're getting a little crazy here. All right, that gets to be a little bit too much. All right, what are you doing, dog? Anyway, um, good to see that my dog is comfortable on the couch behind me. Okay, so why do we do this? All right, well, we do it because we can't measure the entire population. Now, one of the things that you have to make sure that you do is make sure that your sample is representative of the entire population. Okay, you cannot go out and only catch the smallest of squirrels and then say that their average tail length is the same as the average tail length of the entire population. Okay, you cannot only measure the height of female freshmen at Siena College and say that represents the average height of all freshmen at Siena College. All right, you have to have a representative sample to accurately reflect the individuals, the behaviors, and the scores that are found in a population. This is a big issue when it comes to certain statistical tests like polls. All right. This year is obviously a presidential election, and it looks like the two candidates are going to be Donald Trump and Joe Biden. Okay. In the last election, people took all sorts of polls, and they all said that Hillary Clinton was going to win. And then the morning after election day, when I got up, I turned on the television to watch the news, and lo and behold, Donald Trump had won. Now, why were the polls so wrong? They were wrong because they did not use a representative sample. Most of the major media markets are located in New York and Los Angeles and big cities along the eastern and western seaboards. Now, those media companies called people in their local areas, and for good or for bad, urban areas tend to be to vote more Democratic and than the rest of the country, and so that's why they got it wrong. They didn't ask a representative sample. They asked a sample that was skewed toward Democratic voters. All right, and that's why all the polls were wrong on that day. Now, so random sampling. Actually, let's call this a day. We'll start. Let's do a couple more, I guess. Random sampling is a method of selecting a sample in which the individuals are randomly selected from the population. So, for example, if these media companies that we were talking about truly wanted a random sample, they would have called people from Idaho and Wisconsin and Utah and Kentucky and that sort of thing, and not just called people from New York and New Jersey and California. All right. That would have given them a truly random, well, at least a more random sample than the one that they actually got. So, random sampling is defined as a method of selecting a sample in which the individuals are randomly selected from the population. Okay. Now, this should result in a sample that is representative of the population. All right, we'll see, whether the pollsters learned their lesson in the next presidential election. All right, so Um, you've got to choose randomly. You cannot choose, just people whose last names begin with A. You have to choose an A and a C and an M and an L and a Q and a R and a whatever. Okay. Now, random sampling should result in a sample that is representative of the population. All right, but it's not foolproof. All right, just look at the example of the polling in the last presidential election. And an unrepresentative sample, in other words, one that, for example, included more Democrats than Republicans, um, can result in misleading evidence and incorrect conclusions. All right, and so this is why the pollsters in the last election got it wrong. They didn't ask, and I don't know what the percentages of each political party are in the country. I think it's something like 60% Democrat and 40% Republican. I'm not 100% certain of that. And I'm not sure what fraction the independents are. But what they did was they asked 70% Democrat and only 30% Republican. And so they got a skewed sample there. The sample was unrepresentative, and that's why their conclusions were incorrect. Okay. So that is the end of our first video for chapter 2. There will be 3 altogether. So stay tuned for the next video, and I hope you learned something.